Voyager 1, the legendary spacecraft, was launched in 1977 and, even after more than 4 decades, it continues its astonishing journey through the vast, cold universe. This spacecraft began its mission to explore the outer planets, but it soon surpassed all expectations, traveling more than 23 billion kilometers from Earth. Created with 1970s technology, Voyager 1 was only expected to last a few years. Yet, against all odds, it still sends faint signals across the darkness of space. These signals whisper stories from the edge of the universe, where no human-made object has ever gone. Its journey took it past Jupiter and Saturn, where it captured some of the most iconic images in space history. These images provided data that changed how we understand the gas giants and their moons. But Voyager 1's mission didn't end there. It moved into a region never explored before. In 2012, Voyager 1 made history by becoming the first spacecraft to cross the heliopause. This is the invisible boundary where the solar wind from our sun meets the cold, dark void of interstellar space. Scientists once thought this area would be quiet, but Voyager 1 proved them wrong. Instead of silence, its instruments detected weird fluctuations in magnetic fields, mysterious energy waves, and unusual vibrations. These strange signals suggest unknown forces might be at play at the edge of our solar system. It could be interstellar energy interacting with our sun's protective bubble. This bubble, called the heliosphere, was once believed to be a simple shield. But now, scientists think it may be a dynamic zone, influenced by galactic winds and magnetic structures. Voyager 1 might be offering clues to a cosmic energy web connecting distant parts of the galaxy. Some researchers believe Voyager 1 is detecting invisible currents, rivers of energy moving across space, perhaps even carrying cosmic information. This idea, once science fiction, is now being seriously considered in astrophysical studies. Dr. Ed Stone, Voyager's former project scientist, said, "We are seeing something we never thought we'd be able to witness." His words reflect the amazement of the scientific world. Voyager's limited instruments continue to send useful data, even though it takes over 22 hours for a signal to reach Earth. The signals from Voyager 1 are picked up by the Deep Space Network, a group of huge radio antennas on Earth. These antennas are like giant ears, listening for the softest whispers from deep space. The data includes plasma waves, magnetic fields, and cosmic rays that hint at a space that's alive with activity. Some scientists are now rethinking the shape of the heliosphere. Instead of a round bubble, it might be twisted and stretched, like a comet with a long tail. Dr. Merav Ofer, a leading heliophysics expert, suggests that solar and galactic winds may shape the heliosphere into an asymmetrical form. NASA's former chief scientist, Dr. Jim Green, supported this theory, stating, "Voyager 1 is helping us discover that space isn't as empty as we thought. It's filled with structure, energy, and possibly more." His comments underscore how Voyager 1 has rewritten what we thought we knew about space. The discoveries have led to bold questions. Could these unknown forces hint at life beyond Earth? While no direct signs of life have been detected, the strange energy signals make scientists wonder if we fully understand the cosmic environment. One astrophysicist noted, "If we don't understand the energy at the edge of our system, we can't rule out anything, not even life." This uncertainty pushes researchers to explore further. Even Elon Musk, founder of SpaceX, has shown interest in Voyager's data, calling it proof that the universe is still full of surprises. Musk's fascination has sparked new discussions about future spacecraft. Engineers are now imagining next-generation probes that could travel even faster and deeper, inspired by Voyager's legacy. This new generation might reveal more about the hidden forces shaping our galaxy. Voyager 1 has become more than just a spacecraft. It's a symbol of human curiosity, a silent explorer in the dark. Despite running on a plutonium-powered generator designed decades ago, it still works. That small power source keeps its most important instruments functioning. Attached to Voyager is the famous Golden Record, a collection of sounds, images, music, and greetings from Earth. Designed by a team including Carl Sagan, the record was called a bottle in the cosmic ocean. It continues to drift, carrying a message of peace and knowledge across the stars. Many view the golden record as a spiritual message, a reminder that humanity, though small, is curious and hopeful. Voyager's journey is like a silent prayer sent into the void, waiting for someone, or something, to hear it. In recent years, Voyager 1 has recorded even more surprises. One such event was a sudden spike in plasma density, unexpected because interstellar space was thought to be nearly empty. Scientists think this spike might have been caused by a shock wave from a distant supernova. This discovery adds to the idea that space is constantly changing. Voyager helps us understand the interstellar medium, the matter and energy that floats between the stars. NASA experts study this data to map the true boundary of the solar system. Dr. Stamatios Krimigas, a respected space physicist, said, "We need to follow where Voyager 1 has led. It opened a door, and now we must walk through it." His words reflect the drive to plan future missions that continue Voyager's legacy. One such mission is NASA's interstellar probe, which could travel 1,000 astronomical units from the Sun, 5 times farther than Voyager 1. It aims to study the heliosphere, interstellar dust, and possibly new parts of the galaxy. Voyager 1's accomplishments are even more incredible when you remember it uses analog systems and magnetic tape built long before digital computers. Yet it still functions in one of the harshest environments imaginable. This is a tribute to the engineers and scientists who built it. Their vision created a machine that not only survives but thrives in the unknown. It proves that good engineering, even from the past, can stand the test of time. Voyager 1 has changed how we view the universe. It's shown that space isn't just a cold vacuum, but a place filled with shocks, waves, and magnetic activity. These forces are shaped by our own solar wind and by galactic pressures. Some scientists have even proposed that dark matter could be interacting with the edge of the solar system. Although not proven, it's a possibility worth exploring. If true, Voyager 1 might be brushing against a cosmic force we have never seen before. Its data also helps us understand space weather, which affects Earth. By learning how the heliosphere works, we can better predict solar storms and their impacts on our climate and satellites. This knowledge is also useful in the search for habitable worlds beyond our system. If other stars have similar protective bubbles, it could influence how life develops in those areas. Voyager's data helps answer these big questions. Each signal from Voyager 1 is not just data, it's a message of wonder. It reminds us that exploration isn't just about science. It's about asking questions we've never dared to ask and going to places we've never seen. The spacecraft doesn't just measure the cosmos. It connects us to it, making space feel a little closer and a little more understandable. As it drifts farther into darkness, Voyager 1 leaves a trail of curiosity and inspiration. Its signals may one day fade, but the impact of its mission will echo across generations, in science, in philosophy, and in our shared human imagination. Subscribe to our channel and thanks for watching.